In this video, we're going to see how to compute the determinant of large matrices using a technique called cofactor expansion. So imagine we have a large matrix that we're working with and we want to compute the determinant. So to compute the determinant of this matrix, what we're going to do is work along the top row and take the cofactor of each entry, multiply it by the corresponding entry, and then add those all up. So let's see what that looks like when we write it down. So I'm going to take the entry A, multiply it by the cofactor of that 1, 1 entry. I'll take the entry B, multiply it by the cofactor of the 1, 2 entry, and the same with the others. And then we're going to add these up. Now, if you remember what the cofactor of an entry is, it's plus or minus 1 times the minor, right? Times the minor of the entry. And the minor is just the determinant of that submatrix you get when you chop out the ith row and the jth column. And the way we determine whether or not we multiply the minor by plus or minus 1 is by looking at that checkerboard of pluses and minuses. So, thinking along these lines, I know that because the 1, 2 entry in the checkerboard has a minus sign, as does the 1, 4, I know that there is a minus 1 multiplier in each of C1, 2 and C1, 4, but that the others don't get multiplied by minus 1. So I can actually work with the minors instead of the cofactors as long as I keep track of those negative ones in the summation that I have in this expression. So let's write that down. And so now where those minuses are ending up are here and here. So alternating signs in this expression makes it a little bit easier to kind of work through a big problem like this when we have a large matrix and we're trying to find the determinant. Let's see an example. Okay, so in this example, we've got a 4 by 4 matrix, and we're going to compute the determinant of it. And I'll start by looking at the 1, 1 entry and then computing the determinant of that submatrix that I get when I cross out the first row and first column. So I'm going to have 4 times the determinant of 0, 2, 1, 0, 0, 4 minus 1 times the determinant of its submatrix. So I'll cross that out and this out and just keep these parts. So I'll have 0, 2, 1, minus 1, 3, 0, and 1, 0, 4, plus 0 times the determinant of its minor matrix. And we'll have 6 times the determinant of what the matrix is left when we cross out this first row and the column that the 6 is in. So this will be 0, 0, 2. So you may notice that we've made some work for ourselves, right? Because we now have to compute the determinant of 3 matrices. But there are a couple nice things we can notice here that are going to make less work for us. So for one thing, this matrix has a column of all zeros. The determinant of that has to be 0. Just imagine writing that whole wall of zeros here and then the 2 minus 3, 0, and working through what's going to happen. We're going to have one of these factors in every single term. So this whole thing is just 0. Similarly, this thing, well, whatever that value is, turns out that it'll be 0 too, but we're multiplying it by 0. I didn't even need to bother to write that down. This is also 0. And even one more, this matrix has a column of all zeros. So this is also going to just be 0. So really, in the end, our determinant is just this one little piece. 1 times the determinant of 0, 2, 1, minus 1, 3, 0, and 1, 0, 4. And we know how to compute the determinant of a 3 by 3. Right? We copy that and then do our forwards adding up and our backwards subtracting. So let's do it. We'll get minus 1 times 0 plus 2 times 0 times 1 is 0. 1 times minus 1 times 0 is 0. Minus 2 times negative 1 times 4, that's negative 8. Minus 0 times 0 times 0. Minus 1 times 3 times 1. So this is equal to negative 8 minus 3. This is negative 5. Now, in that one we were lucky. We had lots of determinants that were 0, so we weren't going to have to worry about them. But just imagine if all of those entries had been non-zero, it could have been a pain in the neck. But there's a couple of things that we can do to make our lives a little bit easier, and in the next video I'll talk about a few of them.